Geometric construction and locus. Locus is just a path traced by a given set of points with a particular property. So let's say we have 2 points and a straight line is connecting them. So let's say the first point is A and the second point is B. So this is point A and this is point B. Now if you want to find the locus of point that is equidistant from these 2 points, then we need to construct the perpendicular bisector of line AB. So to do that, we place our compass at the first point, let's say A, then open to a reasonable radius that is more than half the length of AB. Then we draw an arc above and below. Then maintaining the same radius, we move to AB and draw an arc to intersect the first arcs. Now we've gotten 2 points. If we connect these 2 points with a straight line, then we have gotten the locus of points that is equidistant from A and B. So the locus of point equidistant from 2 points is the perpendicular bisector of the line connecting the 2 points. So any point on this line is equal distance from A and B. What about the locus of point equidistant from 2 intersecting lines? So 2 lines intersect, an angle is formed. So the locus of point that is equidistant from these 2 intersecting lines is the angle bisector of the angle between the 2 lines. So to do that, we stand at point of intersection and draw an arc to intersect the 2 lines, the 2 arms of the angle. Then we now stand at the intersections. We know how to bisect an angle already, so we draw an arc. Then we start at the second point and also draw an arc to intersect the first one. So we draw a straight line to connect the 2 points, that is the point of intersection, and this is the locus of point that is equidistant from the 2 intersecting lines. So line AB and line AC intersecting at A. What about a point? So the locus of point that is equidistant from a given point is a circle. The fixed point is the center of the circle. We have our first example from WASI 2010. We are constructing a triangle PQR such that PQ is 8.5 centimeters. Now it is always good to make a sketch of the diagram before you start to do the construction. So we have triangle PQR. Now we're told that line PQ, so let's name it PQR. So we were told that line PQ is 8.5 centimeters, and we know the angle over here is 60 degrees. Then we also have this measurement to be 7.5 centimeters. So the sketch can now give us a pictorial view of what we are going to do. So we draw our baseline PQ. So with the sketch, we know we need to draw PQ as a baseline because of the angle, the included angle between PQ and PR. So now we draw the angle which is 60 degrees. we construct the angle which is 60 degrees. So we stand at this point, then with a reasonable radius we draw an arc maintaining the same radius. We stand at this point, then we draw another arc to intersect the first one. So this will give us a 60 degrees angle. So we take our ruler and draw a line through that point and point P. So we draw our line. Now the next thing we do is to measure PR. PR is 7.5 centimeters. So we stand at this point and open our compass to 7.5 measurement. So we stand at P and draw an arc to intersect the line, that is a 60 degrees line. Now we connect Q to R. We connect Q to R. You need to take your time to avoid any constructional error. So we draw the line connecting Q and R. So we finish constructing our triangle. Very simple. Now the next thing to do now is to construct the locus of point equidistant from the locus of point that is equidistant from P and R. So let's move the question to this side. So locus of point equidistant from P and R is the perpendicular bisector of PR. So we construct the perpendicular bisector of line PR. So we know how to do that. So we draw another arc up and below, up and below line PR to intersect the first ones. Then we are also asked to draw a locus of point that is equidistant from Q and R. So we repeat the same process for line QR. So we stand at R and draw an arc below and above the line. Then we stand at Q again. We stand at Q and repeat the same process. So we are at Q now. We draw an arc to intersect the first ones. So now we take our straight edge and connect these points to get a perpendicular bisectors. So draw this line. So we have something like this. Sorry, we have something like this. So that is our second locus. The first one is, let me extend the rule. So we have the first locus to be this. So we adjust our rule and get the connection right. So I think it's right. So now we draw the straight line through the points again. So this is our L1, and L2. So these are L1 and these are L2, and the intersection is L. Now we're asked to draw a circle that passes through the points, the 3 points of the circle. So we have to stand at the intersection of the two loci, then open to one point and draw a line, a circle that passes through all the vertices of the triangle. Now we have to measure the radius of the circle. So you measure with your rule to know the radius of the circle, and the radius is equal to 4.6 centimeters. And we are also asked to measure QR. So we adjust our rule and measure QR. So you can see that the distance is QR is 8.3 centimeters. Now let's take one last example. If P and Q are fixed points and X is a point which moves so that XP is equal to XQ, the locus of X is, so this is going to be the perpendicular bisector of PQ. So that is from JAM 2000.